6.5 Part 2 Solving Radical Equations. By the end of today's lesson, students are going to be able to solve radical equations, but then also check their answers for an extraneous solution. Let's look at our first example when we go to check for extraneous solutions. So we have the square root of 5x minus 1 plus 3 equals x. So just like in part 1, we have to first get our radical by itself. So I need to move positive 3 to the other side. So that gives me the square root of 5x minus 1 equals x minus 3. Remember, you cannot combine the x and the 3 because one's a number and the other one is a variable. All right, to get rid of my radical, I have to square both sides. So that gives you 5x minus 1. And then when you go to square x minus 3, that means you have to FOIL it. So I'm going to write it twice so we can FOIL. All right, x times x gives me x squared. X times minus 3 gives me minus 3x. Minus 3 times x gives me minus 3x. And minus 3 times minus 3 gives me positive 9. Bring down the 5x minus 1. Okay, so since we have x's on the left, x squared, and x's on the right, we need to bring all the x's to one side. So I'm going to first start by combining my like terms on my right-hand side. So that gives me x squared minus 6x plus 9. All right, to move 5x to the other side, I have to subtract it. Okay, to move negative 1 to the other side, I have to add it. So that gives me 0 equals x squared minus 11x plus 10. All right, we are looking for numbers that multiply to 10, that add to negative 11. So two numbers that multiply to 10, that add to negative 11 are minus 10 and minus 1. Okay, let's use our zero product property, setting them both equal to 0, so x minus 10 equals 0. Add the 10 to the other side, and you get x equals 10. Okay, same thing for the other one. Set x minus 1 equal to 0. To get x by itself, add 1 to the other side, and you get x equals 1. All right, now we have to take those two answers, plug them in for x in our original equation so that way we can check. So to check, we take our first answer, which was 10, and we plug it in for x. So we have 5 times 10 minus 1, all under my radical, then plus 3 equals x, so it equals 10. All right, 5 times 10 is 50. 50 minus 1 is 49. The square root of 49 is 7. And then 7 plus 3 is 10. So x equals 10 is one of my solutions. All right, now let's check the other one, because just because one of them works doesn't mean the other one doesn't. So now I'm plugging in 1 for x. So 5 times 1 is 5. 5 minus 1 is 4. Okay, the square root of 4 is 2. And 2 plus 3 is 5, and 5 does not equal 1. So x equals 1 is an extraneous solution. Now let's look at an example that has two radicals. So just like yesterday, get one of the radicals by itself. So this minus square root of x is the easiest to move because it already has the minus sign. So we have the square root of 5x plus 4 equals 4 plus the square root of x. Okay, to get rid of the square root, we square both sides. So that gives me 5x plus 4, and we have to FOIL this right-hand side. So I'm going to write it twice to help me FOIL it. All right, so 4 times 4 gives me 16. 4 times the square root of x just gives me 4 square root x. Square root x times 4 gives me the exact same thing. And then square root x times square root x gives me just x. Before we move on, let's combine like terms over there on the right-hand side. So that gives me 16 plus 8 square root x plus x. All right, so now if you notice you have x's on both sides and you have another radical, so I need to get everything away from this radical. So I'm going to start by subtracting the x and then also subtracting the 16. So that gives me 4x, and then 4 minus 16 gives me minus 12 equals 8 square root of x. All right, normally at this point in time we would divide by 8, but 8 doesn't go in perfectly into 4 or into 12. So instead we are going to square both sides to get rid of our square root. So on this left-hand side it does mean 4x minus 12 times 4x minus 12. And we are going to have to FOIL that, okay? 8 times 8 gives me 64. Square root x times square root x gives me x. All right, let's work on the left-hand side now. So 4x times 4x gives me 16x squared. And then 4x times 12 gives me minus 48x. Then negative 12 times 4x gives me the exact same thing, negative 48x. And then negative 12 times negative 12 gives me 144. Okay, let's combine like terms on our left-hand side. So that gives me 16x squared. And then 48 plus 48 gives me negative 96x. And then plus 144. All right, since we have x's on both sides and an x squared, we need to bring everything to one side and set it equal to 0. So I'm going to subtract 64x, subtract 64x. That leaves me with 16x squared minus 60x plus 144. So those are really big numbers, so I'm hoping there's a greatest common factor that goes into all of them. So I'm going to see if the 16, my a, goes into all of them. So that leaves me with x squared minus 10x plus 9, so it does. So now I'm looking for numbers that multiply to 9 that add to negative 10. So that gives me x minus 9 and x minus 1. Use your zero product property. So x minus 9 equals 0, x minus 1 equals 0. So to get rid of my minus 9, I add 9 to both sides. So x equals 9. To get rid of my minus 1, I add 1 to both sides, so x equals 1. All right, now we have to check to make sure we don't have an extraneous solution. So I need to plug my 9 and my 1 into my original equation. So let's start with the 9. So I have 5 times x, so 5 times 9, plus 4 minus the square root of 9 equals 4. Okay, so 5 times 9 gives me 45, plus 4 simplifies to the square root of 49. All right, let's see. So the square root of 49 is 7. The square root of 9 is 3. And 7 minus 3 gives me 4. So x equals 9 is definitely a solution. X equals 1 could also work as a solution, so we need to check. So plug in 1 for x. So 5 times 1 plus 4 minus the square root of 1 equals 4. Okay, 5 times 1 is 5 plus 4 is 9. Now let's keep simplifying. So the square root of 9 gives me 3. And then the square root of 1 is 1. 3 minus 1 gives me 2. Since 2 does not equal 4, x equals 1 is an extraneous solution. So this one does not work.